Okay, hello. Let's get into our first topic. First topic is force vectors. Okay, now we have seen some quantities be used in physics, and we have seen that a position can be defined by using 3 points in space, in universe in general, with respect to a reference point. Of course, there are different physical quantities, so we know what the pressure is, what the temperature is, and there are also additional quantities like the velocity, acceleration, which we have seen in physics course. Now, there are two different type of quantities that we define. One is a scalar quantity. So what is scalar? It's a value which can be defined by a positive or negative number. So you just define a single number at a point. So what's that? For example, temperature. For example, pressure is a scalar quantity because it's a point-wise quantity or the concentration of something. But in fact, we have also vectors. Vectors are defined as defined by a direction and magnitude. For example, the car has a speed, right? You see it in front of the car, but the direction along with the speed, the magnitude, gives us a vector. So we know that we know in which or towards where the car moves. Certainly the velocity of a car is a vectoral quantity in that case. Okay, now generally we show the vector by a letter and then arrow on it, which means that it's a vector quantity. Force is also a vector, right? And we draw a line with an arrow. The length of the line tells us the magnitude of it, and the arrow shows the direction. So this is a vectorial quantity. So let's see how the operations on vectors. Okay. So we can begin by vector addition. Sometimes we need to add two vectors. For example, just think that an aircraft is flying in the air. Okay, a plane is flying in the air, and of course it has a velocity. But when there is a wind, velocity has to be calculated along with the wind speed and wind velocity. So certainly this means that we have to sum up two vectors. Okay, what we do is very simple. Basically, we put two vectors, the beginning of two vectors at a point, and we just draw the vectors. So this is the first step. There are two approaches that we use. First one is the parallelogram. Method. So what's the parallelogram method? Certainly parallelogram method, in case of a parallelogram method, we draw a parallelogram by using the vectors. So first we draw the first vector A, and then we draw the second vector B, and then we draw in another line which is parallel to the vector B and draw a line that is parallel to the vector A, and then we draw a line from the point where two vectors are intersecting each other and to the other edge, other vertex of the parallelogram. And this, the third line, gives us the summation of these two vectors A and B, okay, as you see here. What is the other technique? Again, other technique is the triangulation. Now triangulation works like this. First, we draw the first vector, A. And then beginning from its endpoint, we draw the second vector, B. So what we do is, beginning from the beginning point of the first vector to the end point of the second vector, we draw a line and put an arrow on it to the end point of the line. So this vector, or this, the third vector, gives us the magnitude and direction of our resultant vector, let's say. So the summation of the vector A and B. So this method is called triangulation. How about the multiplication with a scalar? Now just think that the vector, our vector A has a magnitude, okay, and we multiply it with the scalar. It can be any number. It can be even a negative number. So what we do is very simple. Certainly, multiplying a vector with a number will change its magnitude. So as a result, for example, if you multiply a vector with 0.5, this means that its magnitude will decrease in will decrease and will become half of the initial vector. So the length of the line has to be half of the first line in that case. So this is multiplication of a vector with a scalar quantity. Sometimes we use it, right? We will see when we begin to solve the problems. Last thing is decomposing a vector into its components. We may need to decompose a vector into its components. So here, for example, I want to know a velocity of a vehicle in certain direction, maybe, or a machine part in certain direction along certain axis. So how will I do that in that case? Now here I have two lines. One line is A, the other line is B, and certainly I have my vector R, okay, and I want to find its components in the direction of A and in the direction of B. How will I do that? Now remember how I sum up the vectors. So certainly when I decompose a vector into its components, summation of the components shall give me the original vector, R in this case. Okay, so what we do is like this. We draw a parallel line, okay, so we draw a parallel line. Line parallel to A, and then we draw another parallel line to B. Now I have these two parallel lines. Certainly my components along A and B must be on these lines. So beginning from the origin of the resultant force, first I draw the first vector and then I draw the second one. Now I have the vector A and I have the vector B. If I look at this figure carefully, I can easily see that sorry, I will hold you for a second. Okay, I lost my slide. Okay, if I carefully look at this figure, I see that summation of A and B will give me the original vector or my resultant vector. So this is how I decompose a vector into its components. Now there exists a second operation, subtraction of one vector from the other one. Again, let's assume that I have two vectors A and B, and I want to find A minus B. Sorry, I'm new to this software. So A minus B. This is what I'm looking for. Okay. And certainly A minus B will give me the resultant one. So what I do is, in this case, now taking the negative of a vector is multiplying it as with minus 1. Certainly this means that the negative of a vector will have the same magnitude but has opposite direction, as you see in the figure. Okay, and then now I can do vector summation. I can use any method, triangulation or parallelogram method, certainly, and then I form the resultant. I obtain the resultant vector. Of course, the point is we use geometry and geometric graphical methods, and therefore we use geometry. Now, you may use draw a vector on a paper and measure it with a ruler, but better is to use some trigonometric or geometry principles. So first thing is the sine theorem. Sine theorem tells me that if you have a triangle with angles alpha, gamma, and beta, with the edge lengths A, B, and C, A divided by sine alpha, so the alpha sees the edge A, right? So the angle or the edge length the edge divided by the angle that it sees is equal to the length of the edge divided by the angle sine of an angle that which sees the edge. So A divided by sine gamma, sorry, this has to be alpha, by the way, this is wrong. So let me write it here. Okay. So the thing is A divided by sine alpha is equal to B divided by sine beta and that's equal to C divided by sine gamma. So this is the expression that I have. This is the sine theorem. A divided by sine alpha is equal to B divided by sine beta and C divided by sine gamma. Please correct the formula. Okay, we have another theorem. So that is called the cosine theorem in that case. So what cosine theorem tells us that if you know the edge length of a triangle, two edges, the lengths of two edges of a triangle, along with the angle between these two edges, you can find the length of the third one. So now in mathematics, this is like this. So if you know the edge length B and edge length A and the angle gamma between them, then C squared, the square of the length of the third edge, is equal to square of the length of the first edge, A. So A square plus B square minus 2AB multiplied by cosine gamma. So this is called the cosine theorem, in fact. Okay, we will see in detail how we are going to use these fundamental laws, fundamental things when we begin to solve the examples.